What's going on, guys? Let's do this problem right here. The question is asking terminal velocity, and terminal velocity also acceleration when the velocity is equal to half of the terminal velocity. So let's see how we can do this. So first of all, we know the equation for viscosity. Viscosity is provided, so let's see. So the equation for viscosity is mu is equal to rho sphere. So whatever the sphere we have, that's the density of that sphere minus rho liquid divided by the terminal velocity multiplied by 2 over 9 gr square. So this is the general formula we use to find the viscosity, but in this case they are asking to find the terminal velocity, so we can rearrange this equation to find the terminal velocity. So let's see how we can do this. So first of all, we have Vt right here, so I can swap this one to the other side of the equation and bring the viscosity to here. So let's see. Therefore, this is going to be equal to Vt is going to be equal to rho sphere minus rho liquid divided by the viscosity, that's mu, multiplied by 2 over 9 gr square. So g is going to be acceleration of gravitation, right? So here we have all the information right here, it's provided. So let's apply that one here and find the final answer. So rho density of the sphere is provided, that's 2715, so I can apply that one right here. So this is gonna be 2715 minus rho liquid is provided, that's 1261 divided by the viscosity that's provided 1.2, so I can divide this one, multiply by 2 by 9, and the acceleration of gravity is going to be 9.8, so I can multiply that one, and we have r square that's also provided, that's 2 millimeter. First of all, I have to convert this one into SI units, so I have to divide this one by 1000. So if I divide this one by 1000, that's going to be 0.02 meter, and if I calculate this value, this one comes out to be 0.0106 meter per second. So we found the terminal velocity. Now we have to find the acceleration when the v is equal to half of the terminal velocity. So let's see how we can do this. So first of all, what is the acceleration? To find the acceleration, I can use this formula, that's F is equal to ma. So in this case we have to find the acceleration, so I swap this equation around, and a is going to be equal to F over m. So in this case we are going to have mg acting downside of this sphere, and also we are going to have buoyancy force acting upside. Also we are going to have drag force. So drag force, let's say buoyancy force bf, so bf, and also we are going to have drag force acting upside, so that's going to be fd. So those are the forces that's going to act. So let's see. So if I put all the forces together, so this is going to be bf is acting upside, so it's going to be positive, and others are acting, let's take the upside negative. So downside, if I take the downside positive, mg is going to be positive, mg minus bf minus fd divided by m. So to find the m, I can use another formula. So first of all, we have the information about rho, so we can, the formula that's related with rho and the mass, so we can use rho is equal to m over v, therefore m is going to be equal to rho v. So I can write rho v instead of m and see what happens. So this is going to be rho v, and we have mg right here, so instead of mg I can write rho vg. So rho vg, and buoyancy force, that's gonna be so instead of buoyancy force is basically the weight of the liquid pulled by this sphere, so that's going to be same thing, so that's going to be rho vg liquid. So this is going to be rho vg liquid, and for this drag force, I had to use Stokes law. So Stokes law equation is 6 pi mu RV. So instead of drag force, I can substitute that one right here. So this is going to be 6 pi mu RV divided by rho V. And now this is rho Vg for sphere, this is rho Vg for liquid, and this is 6 pi mu RV and rho V. So we have wrote the equation right here, so we can apply all the values. So let's apply all the values. So first of all, we have rho for the sphere that's provided, so we can apply this one to here. So this is going to be 2715, and volume of the sphere is going to be 4 over 3 pi r cube. So 4 over 3 pi r cube is the volume for a sphere, pi r cube multiplied by g. Then we have same thing for the liquid. So for the liquid it's also going to be same thing, so it's going to be 1261 multiplied by 4 by 3 pi r cube multiplied by g, and we have 6 pi mu that is provided 1.2. Then we have r right here. I keep the r so we can cancel r and then substitute, so I keep the r here and multiply by v. Yeah, let's put the v for now and let's substitute later. So we have rho v in the bottom, so instead of v I can substitute 4 by 3 pi r cube in the bottom too. So this is going to be rho is actually for the sphere, so that's going to be 2715 multiplied by 4 by 3 pi r cube. And if I solve this one, I can cancel over the r, one of the r. So if I cancel this one, this is going to be square, this is going to be eliminated, this is going to be square, this is going to be square, and then now we can substitute the 0.02 for the r and find the final value. So if you substitute the 0.02, you will get 2.61 meter per second square, and that's the final answer for this question. I hope you guys like this video. See you next time.